So today we're going to be learning about multiplying and dividing integers. And just like modeling addition integers and subtracting integers, multiplying and dividing integers can be modeled with integer chips or a number line. How would the integer chip model of 2 times 5 look? So this is like from elementary, if you were showing 2 groups of 5 or 5 groups of 2. And so this is, there are 2 rows of 5. So 2 times 5 is, of course, 10. So what would the number line model of 2 times 5 look like? And this would look like there are 2 groups of 5. So 1 group of 5, 2 groups of 5. And so you can show this on the number line, 1 group of 5, 2 groups of 5. You can show it on the number line, or you can show it with integer chips. And you can do it with negative numbers also. So let's model 5 times negative 3. So we're going to think 5 groups of negative 3. So with integer chips, we're going to show negative 3, negative 3, that's negative 3, and we're going to show 5 groups of it. That's 3 groups, 4 groups, 5 groups. Okay? So what is that answer? They're all negative. If you count them up, it's negative 15. So 5 times negative 3 is negative 15. Okay? What would 3 groups of 5, negative 5, look different? How would 3 groups of negative 5 look different? So I would say this is a group of 3. This is a group of 3. This is a group of 3. This is a group of 3, and this is a group of 3. So how many groups do I have? I have 5. 1, 2, 3, 4, 5. 1 group of negative 3, 2 groups, 3 groups, 4 groups, 5 groups. So this, of course, is going to be negative 15. So that's the way that you show multiplying integers with integer chips in a number line. So you could, just the way that you do it with positive numbers, you can do it negative, just these are instead in red and this goes to the left. So what if we are multiplying 2 negatives? Remember, another way to think of a negative sign is the opposite of. Okay? So, negative 2 times negative 2 can be read as the opposite of 2 groups of negative 2. So if I have negative 2 and I have 2 groups of negative 2, so that's just 2 times 2 is 4. Well, these are all negative, but the negative and the negative, say, is the opposite of. So I've got to do the opposite of negative is all of these being positive. So whenever you're multiplying 2 negatives together, your answer is going to be positive, and it's because it's the opposite of, and so it shows 4 positives. Since division is the opposite of multiplication, how do you think the models would be different? So instead of building a group, you would be taking a group and breaking it down, splitting it apart into smaller pieces. So can you guess what the integer chip model of negative 10 divided by negative 2 would look like? So it would be 10 negative chips divided into groups of 2, and this would be a positive 5. 1, 2, 3, 4, 5. 5 groups. and they would be -2 and divided by -10 divided by groups of -2. So let's try it. If we have integer chips and we have -12, so I would draw that's -12, and these are divided into 3 groups. 1, 2, 3. How many groups do I have? Or how many are in a group? How many are in each group? There's 4. 1, 2, 3, 4. 4 per group, and they are negative, so -4. So -12 divided by 3 is -4. And on the number line, it would look similar. It would be, we would say this is from 0 to -12, and we would say this is a group of 3, and this is a group of 3, and this is a group of 3, and this is a group of 3. And how many groups of -3s do we have? We have 1, 2, 3, 4 groups. So after looking at the multiplication, division, integer problems, what can you determine about how to decide what the sign of the answer will be? Well, we're used to 2 times 5. Those are both positive, so we know our answer is 10. It's always been 10. So it's positive 10. And then we have 5 times a -3. We saw that if you have integers, -3 integers, and you do them 5 times, you're going to get -15. And then we showed groups of 10 in red integers into groups of 2, and it was 5 groups, and that's positive. And then we showed -12 divided into 3 was -4 groups. And we showed -2 times -2, a negative times a negative was a positive. So you multiply or divide as you normally would. Then, if both signs are positive, the answer is positive. If both signs are negative, the answer is positive. If one sign is positive and one is negative, the answer is negative. So you'll want to jot this down in your notes and know that this is the way that it works. And then I've got a little thing that will help you. You'll want to put this into your notes. So first, write this down, and then I'm going to show you the other page, and you'll write that down, and we'll go through what that means. So did you get this down? Both the signs positive, answer positive. Both the signs negative, answer negative. One sign positive, one sign negative, the answer is negative. So a quick way to refer to this, now this only works with multiplying and dividing. It doesn't work with adding and subtracting. Is you can make this tic-tac-toe board, and you can put a diagonal of a positive, 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 and fill in all the other spaces negative. And then write this down, and then come back, and I will show you how this works. So let's say you have a positive times a negative. So you would do this as normal. 10 times 3 is 30. But then to determine the positive and the negative, you'd look over here. Positive times negative equals negative. So you would make it a -30. then this one is a negative times a positive. And so you just do it like normal. 5 times 8 is 40. And then you have a negative times a positive equals a negative. So that's negative. And you can also look at it this way. A positive times a negative is a negative. And that's this one. And a negative times a positive is a negative. So it works no matter which way you work the grid. And then a negative divided by a negative, so 6 divided by 12 divided by 6 is 2. And then we've got a negative, negative, so my answer is positive. So it's just positive 2. So that's the way this works as a little helpful hint tool that to let you know when multiplying and dividing what the sign is going to be. So here's your homework check. And this is, so on this first one, you don't have to answer it. You just have to say, is the answer positive or negative? So positive or negative would be the answer. And then this one, which equation is being modeled? So you want to make sure and include that the answer in your equation. So what's going on here? And then solve this problem. Negative 15 times 3. So make sure if it's negative to include your negative sign or positive, just leave it the way it is. So this is your homework check.